So all of the lessons are all in our classroom. If you have a printer, awesome, you can print them out. If you don't have a printer, not a big deal. You can either fill them out directly on the Google Doc, that works, or you can just take notes by hand and write the important things. I will be posting the filled out versions of all of these. So in addition to posting this video that we're about to record, I will post the full solutions for each worksheet so that if there is anything you missed or you didn't write everything down, you'll have an opportunity to go back and do it if things are going a little too fast. I'm going to try to go through at a reasonable pace. If you need me to slow down or repeat something, please let me know. And people have already figured out the raise hand things and you're all doing great with that. So we'll just continue using that system. So looking here, we have our first lesson, and hopefully everybody can see my screen that I'm sharing. If for some reason you can't, just let me know in the chat box. So we're going to start with our first unit, which is our introduction to functions. And this is really what a huge part of this course is all about, is functions. How do we use them? What do they mean? And how do we transform them? So there's two main definitions that we have to go over, and I've already written them out just because they're a little long, but we want to talk about the difference between a relation and a function. So a relation is a set of ordered pairs. Values of the independent variable are paired with values of the dependent variable. So when I just have a bunch of ordered pairs and not really an equation, that's referred to as a relation. Next, we have a function. And it's a relation where each value of the independent variable corresponds with only one value of the dependent variable. So a function is a special kind of relation where if I have an x value, it only corresponds with one y value. So we'll go through some examples of that and what that means, because reading it as these definitions is a little unclear. So let's go through our first example. So if I'm given the graph of a relation, so I have a curve on a graph, and I want to determine if it's a function, what I'm going to do is I'm going to do what's called the vertical line test. And basically what that means is I'm going to put a vertical line through my function, and the vertical line can only be touching the curve once at any point. So as long as the curve is only touching my function once, then it's a function. So for example, with relation A here, if I draw a vertical line and I picture this vertical line sweeping across, and I move it over here, if I draw any vertical line, it's only going to be touching my curve once at any given time. So because of that, we would say that relation A is a function. So let's try it again with relation B. So in this case, I'm going to draw my vertical line, and I want you to picture it sweeping across the whole curve. If I look here already, it's touching my curve at two different places. So because of that, it's going to fail our vertical line test. So what I would say is I would say not a function, failed vertical line test. So now let's do that again with relation C here. I start by drawing my vertical line. And again, I want you to picture it sweeping across the whole thing. So I want you to picture it just sweeping across my whole curve, which in this case is just a line. And at no point will it ever touch it twice. So therefore, it is a function. Next, we have relation D. So same idea. I'm going to draw a vertical line. And already with my first vertical line, I notice that it's touching 2 times. So that's enough for me to say, not a function. And if you're going to say it's not a function, you need to say your why. So I would say it's because it failed the vertical line test. So that's how I go about figuring out if it's a function with a graph or if I have a picture. Now we don't always have a picture. So if I'm just given ordered pairs, there is a way for me to tell if it is a relation or a function. So when I look at my ordered pairs, I have to look at all of my x values and look for ones that are the same. So I have 1, 1, 2, 4, 5, 8, 1, 7, and negative 2, 5. So if I look here, I'm going to point out the ones that have the same x values. So if I look here, because I have 2 of the same x values with different y values, I have 1 independent. So my x ones are always my independent. And that 1 independent has 2 dependents. So because of that, therefore, it is not a function. So again, because I have 2 matching x values, so I have 1, 1 and 1, 7, and these 2 matching x values have different y's, that makes it not a function. Let's look at relation F. So the first thing I'm going to do is I'm going to look at all of my x values. If I look here, I have 0, 7, 3, 2, 6, 7, 8, 2, and 9, 4. None of my x values match, so right away I can say that we have a function. And we're going to do some more practice with this, so if you're still feeling a little confused, there's still time. So let's do a table of values. And the table of values is very similar to our ordered pairs. It's just our ordered pairs written in a little bit of a different way. So similarly, what I want to do is I want to see if I have any of the same x values. So what I'm going to do is I'm going to look up and down this column here and look for any matching numbers. So I have negative 3, negative 2, negative 1, 0, 1, and 2, and none of them are the same. So I can say right away that this is a function. Next, I'm going to look at relation H. So same idea. I'm going to look up and down my x column, looking for any of the same numbers. So if I look here, I have 2 1s. So that means we have 1, 5 and 1, 1. That can't happen for it to be a function. Each x can only correspond to 1 y. So that is an issue right here. And if I look, I actually have another issue as well. I have this 2 and 2. So I have 2, 4 and 2, 2. That also can't happen. So what I would say is I would say that there are 2 dependents for 1 independent. Therefore, it is not a function. Now, one important thing to note is it can be the other way around. That works. So if I look over here, I have 1, 1, and 2, 1. I have two numbers in my y column. That's okay. That works. It's just I can't have matching numbers on my x's. That is really the only rule to this. So just be careful there because that can get a little confusing. Okay, so now what if I'm given an equation? Oh, yes, Ethan, you can turn your mic off and ask, or type in the chat if you want to.
Is it possible for a function to have repeating? No. Is it possible for a relation to have non-repeating dependence?
What do you mean by that?
Like, let's say a relation. Let's say there's a function, right, where a relation has like no repeating dependent variables.
Yep.
But is it possible for a relation to have no repeating dependent variables?
So if it's so for a relation, the rules really don't apply. So as long as I have a set of ordered pairs, really you can have whatever ordered pairs you want, and that classifies as a relation. Then, in order for it to be a function, it has to only have one dependent for every independent. So I could have like all the same y's, and that's fine. But I could not have the same x's corresponding to different numbers. That's really the only rule. And the way to think of that too is if I were to go and graph those points, so if I graphed relation H and I put all of those onto a Cartesian plane, it would actually fail the vertical line test because it has those matching x's. Is that kind of what your question was, or did I misunderstand it?
Yeah, that was my question.
Okay, awesome. Okay, so what if the x and y values are the same? Like in H, we have 3 and 3. Oh, that is okay. They can be the same as each other. That is fine. We just can't have two matching x's. So see here, we have, sorry, I have the highlighter still on, how we have 1 and 1 here. And that one corresponds to a 1, and this one corresponds to a 5. That is a problem. But having 3 and 3 is totally okay. It just matters that in this column, I have 2 1s. That's the big issue here. That makes it not a function. Does that clear that up? Okay, awesome. All right, so let's go on to example 4. And now we're going to look at some equations. So how do I know if the relation is a function? So if I plug in any value of x, I should only get one y. So that's what I'm going to write here. Plug in any x, should only get one y. Right? So same idea. If I have one x value, it should only correspond to one y value. If it corresponds to more, then if I were to graph it, it would fail the vertical line test. So all of these things we're doing are actually all connected and all kind of explaining the exact same thing, just in a little bit of a different way. So let's try a few of these examples. So you can plug in any x. I'm going to plug in x equals 0 to make our math easier, but you can really do whatever you want. So I'm going to say if x equals 0 for the first one, and all I'm going to do is instead of writing an x, I'm just going to write a 0. And then we just simplify using BEDMAS. So y equals 0 plus 6, y equals 6. So because I only have one y value here, I can say yes, it is a function. And you'll notice while I go through the algebra, I'm going to be putting in all of the intermediate steps. You do not have to do that, If you are comfortable, you could have skipped right to 6, but I just want to make sure everybody knows where my numbers are coming from. And if they cut out for a moment or anything, that they knew what I was doing. Okay, so let's try relation J. So you can sub in whatever you want for X. I'm just going to sub in 0 again to make my math easier. So instead of writing an X, I'm just going to write the 0. And then we just simplify using BEDMAS. So 0 plus 0 minus 6. So then I get y equals -6. So again, because I only got one y value, that means that this is a function. Okay, so now let's look at relation K. And again, I'm going to sub in x equals 0. If you want to sub in something different, not a problem. So I'm just going to rewrite it with my x's as zeros. And I'm just going to simplify and solve for y. So 0 squared is just 0. 12y squared equals 25. But that's y squared, and I just want y. So I'm going to square root this one and square root this. So that will give me y equals plus or minus 5. So remember, when we square root, we have to include this plus or minus here. And the reason why we have to do this is because positive 5 squared gives us 25, and negative 5 squared also gives us 25. So there's actually 2 values for y here. So that breaks our rules. So I would say, therefore, this is not a function. And the reason it's not a function is because there are 2 y values. And that is our last thing that we need to know for our functions. Those are different ways of telling if it is a function or just a plain relation. Yeah, Ethan.
Could you justify whether it's a function or a relation based on the parent function or relation?
Yes, you can, actually, as long as all of our transformations, and we'll get to that for anybody who's kind of unfamiliar with this, we will be getting to what I'm about to say in lesson 1.6. But as long as all of your transformations are applied correctly, so they're all in the right spots, then if the parent function was a function, then you're still good to go, because all of those transformations will keep it as a function. Yeah, I'm trying to think. I don't think that there's any off the top of my head that would change that. But for the most part, you absolutely can.
Okay. Thank you.
No problem. Okay, are there any other questions? Because we're also going to be doing 1.2, which is also quite short and pretty straightforward. So before we move on to that, is there any other questions? If you also have a question that you feel like is just for you, feel free to send me an email, and once we're done here, then I can address it. Or if you want to just wait until we're done recording, we can do that. Okay, so just so that I can keep these 2 lessons separate, I'm just going to briefly stop the recording.